Here, maybe here we still have a little time left. Maybe I can go through my one that applies sklearn here.
Okay, yeah.
Shit, I stopped my recording. I wonder why. Let me share my screen. Here, could you post the? Could you post like? Could you like make those public and like post in Discord or something? Post them somewhere. Like the notebooks. That'd be nice.
Yeah, for sure.
Okay. Okay. Here, maybe. Wait. Here, how about this? I'll let you guys choose the algorithm. I have like a bunch of. So I have a bunch of. Maybe not one of the videos. Is there any? Okay, you guys can vote. Here, vote on these three. Unless you guys, we can also end this meeting right now. Two and three. Okay, three. Okay, let's go over this one. Okay, so here, let's just look at the chart first. Where is it? Right here. It's pretty good. Okay, so let me just go through this real quick. Okay, so what this basically does is that it maximizes the Sharpe ratio of a portfolio. So we take like past. Wait, I can't remember how much data was. We take the past 50 days of data and we optimize the Sharpe by like adjusting the allocation ratios of these four tickers. Okay, so this is the total market index. This is total like aggregate bond index. This is like some agricultural commodities index, and this is a VIX tracking ETN. Well, these aren't indexes; these are ETFs, but they usually track some index. So what it does is it like chooses some like ratio, like say 0.25, 0.25, 0.25, 0.25 of these, or it can be 0.3, 0.3, 0.2, 0.2. So it adds up to 1, so we can allocate 100% of our portfolio. And so what it does is it adjusts these ratios so that we get the best Sharpe based on the Sharpe in the past 50 days of data. Okay, so what? Okay, this stuff isn't really very interesting. So what it basically does is it just collects a bunch of the data and feeds it into our model. Okay, so, and then like whatever the model spits out, it allocates. Okay, so here, what does this do? Okay, this is kind of weird, but it makes like all random functions the same if you use the same seed, so that our results are reproducible. And to be honest, I sort of messed around with the seed to get a better Sharpe ratio, but nobody needs to stitch. Okay, so I don't know if you guys are familiar with Keras, but okay, so here I just built a model. It's a first LSTM layer. It's basically, if you guys are familiar with like a neural network layer, it has a bunch of neurons. But LSTM, what it does is save the previous. It saves the past data, and it remembers past data. And this is so why would this be important? Like, why would you want to remember past data? Well, if you're using financial time series, time is usually temporal, right? So the past data can be important because, like, say you feed in 50 points of data, then you feed in another 50 points of data. The 50 points of data before that might have an effect, right? Because, like, it's all time. But if you're doing, like, say you're doing image classification and you're identifying different breeds of dogs, right? You first identify a greyhound, then you identify a chihuahua. It does not make sense in this case to use an LSTM, right? Because the past data has no effect on the future, because you can feed in, because like time series, like you have 50 points of data, then you have another 50 points of data. It's sequentially ordered, but that same logic does not apply to classifying images. Okay, so we flatten it. So our input shape is like we use a matrix. We use a 2-dimensional matrix for inputs. I'm not sure what the max is. I think you can like put in high dimensional stuff. Like it's pretty crazy. You can like do stuff with like x, y, and time. So you can do some crazy stuff. However, like if you think about a matrix of neurons, that's not very flat, right? You need to use the final flat layer of neurons to get the final flat layer of outputs, because our outputs is 3 neurons that are flat. I mean 4 neurons. So we have 4 neurons, one for each ETF here. And so it's just basic. So dense is basically vanilla neural network layer. And softmax, what that does is it makes it so that everything sums up to 1. So say you have like 5, 5, 4, 4. That sums up to or 18. However, do some like I think it's exponentially weights each thing and divides it by everything, and then blah blah. And then it does all that stuff, and then like all the neurons will add up to 1, and that's very convenient. So that we don't go like, so that we only allocate 100% of our cache, so we don't like go over. And then here we have a custom loss function. So the loss function is how the neural network is scored, right? And how these neural networks, let me draw this out. Okay, so say this is our loss function, and then we have some like input here. So this is just 1-dimensional. I mean, it's 2-dimensional. And so let's just say this is the loss. And this is one input X. And so it might look like this, right? And then what it does is so say we have some X value here. Then it wants to go down here, the steepest way, might go up here, keeps going down, goes up, goes down, until it gets here. Well, we might not guarantee, it's not guaranteed that we get to the most optimal location, but we can get pretty good. We can get pretty good results. Like maybe here, maybe here. I don't know. So this is gradient. So this is called gradient descent. Like just think of it like a ball rolling down a hill. So this is a ball. It just goes up here. It's trying to roll down to a hill, down the hill. And so say if we have it like 2 dimensions. So the ball could like go like this down here. So gradient descent wants to minimize this. And what is this? So, and it keeps changing the predictions. It keeps adjusting the predictions until it reaches like a acceptable, well, until it like reaches like converges to some loss. And so what is here? I just calculate the Sharpe ratio. Okay. So if you remember, these are our input. So these are our 4 predictions. The weights for these, this is what we want to predict. And then so I normalize. Okay, self.data is the time series for all of them. So yeah. So say the stock data is like 100, 220, 50. Okay, so this is one of the ETFs. And then blah, 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 down to like 50. So we have some data for like VTI. And then we have some data for AGG, etc., etc. And then like blah, 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 down to like 50 points of data for each of them. 50 points for each. And so I put that in a matrix. And so if you think about it here, so I divide everything by the first element. So if you divide everything in the matrix by this, then you basically invest $1 in each. $1, $1, $1, right? Because it's kind of weird. Like this is called NumPy broadcasting. So if you divide like a 4 by 50, so this is this is 50 by 4. This is 50 by 4, x4. And if we get the first here, this is a 4 element vector. So divided by this 4 thing, this 4 vector. what it does is it uses this vector. It takes the first element, divide this by that value, divide this by, so say it's like ABC. Let's just say this 4-element vector is ABCD. It divides all these values by A, divides all these values by B, divides all these values by C, and divides all these values by D, like each individually. And so what that does is it makes it so that, like, say it basically simulates us buying $1 of each. And then I take the coefficients. And then if you remember earlier, this is the 4 values. So we multiply each. So we like basically, say we invested, so say this is $1, $1, $1, $1. And then we have some, like, this is our allocation ratios: 0.25, 0.25, 0.3, 0.2, right? And then we take each of the series. It'd be 0.25, then be some 0.27, something, I don't know, 0.23. And so it, like, same thing. Instead of, like, we just multiply this by 0.25, multiply this by 0.25, multiply this by 0.3, and this by 0.2, right? That's what this does here. And then we add up. And then so what is our portfolio value? We'd add up the value here, the value here, value here, value here. So we'd add all of these up and put it into a value here, right? Put it into value here, value here. Because think about it. If we allocate 25% of our portfolio to this, 25% of portfolio to this, 30% of our portfolio to this, and like put 20% of our portfolio to this, then our portfolio value just adds all of these up based on the weight. So now we have just a 1/50, right? And then now we just plug into the Sharpe formula. This is the Sharpe formula. You guys, wait, no, this is percent change. Okay, so I just calculate the portfolio returns. And if you remember the Sharpe, I don't know if you guys know the Sharpe ratio formula. Let's look it up. So this is the expected return, and this is the standard deviation. We don't care about risk-free rate because it's basically 0, and it's like, let's just not worry about it. So expected return, if you know about, like, expected value, so if you roll a die, the expected value is the average of all the die, so it's 3.5. 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals 21. Divide by 6 is 3.5. And so what we can do is, so what's the expected value of the portfolio returns? It's just the average, right? Earlier we averaged up 1 plus 2, 1 through 6, we averaged up that. So we just average the returns, and we take the variation, the standard deviation of the returns. We get the Sharpe. And so since we want to maximize Sharpe, we minimize loss. This is the values what we want to minimize. We take the exponent and then we negative. Think about it. So if you have a Sharpe of 1, right, and you take the exp, you call the exp, and exp is e to the, so e to the 1. That's like 2.7, right? Well, let's make it bigger, like e to the, here, wait, I need to just, and let's do e to the -1, since we're taking the negative. Okay, that's not too shabby, whatever. But what happens if we get a Sharpe of 10,000? Oh shoot, that's too small. Let's just we get a Sharpe of 10. Well, our loss becomes really small, smaller and smaller. That's why we take the negative of the Sharpe here when we take the exponent. And the reason we take the L exponent is because positive negatives, we want to make everything positive. However, if you think about it, like, let's graph it. Dude, the pencil sucks. Paint pencil sucks. I don't know why people use it. This is an exponential function, right? And you notice something. All the values are positive, but the negative values here, when the negative values here are smaller than the positive values here, right? So what we do is it allows us to have all the values to be positive, but the negative values are still the original negative values are smaller than the original positive values when they're exponented. Hopefully that makes sense. Does it make sense? It's like x here is negative, and so it should be smaller. And so here, the exponent is smaller than this. Does that make sense? Yeah, let me just see the chat. Hopefully that makes sense. Okay. So here, let's just do the number line. So like originally, we can have like so this is, let's just say this x, right? And this is 0, right? We can have positive negatives. But now, once we take the exponent, it looks like this now, right? This to this. So the smaller value, hopefully that makes sense. Okay. Okay, so this is a very interesting neural network because this is where, so like usually we would want to calculate mean squared error or something. So we take the actual values to see how far we off, and then we'd subtract it by this and square all the values and add them all up and stuff, you know? However, here we actually don't use the actual values because we don't care about, because there are no actual values, right? This is very unique. Like usually we'd have like right true to like make our model to update our weights to make it more accurate, but here we don't. We just want the gradient descent. We use the model. We use Keras we use the neural network for everything except prediction. So if we wanted to predict stuff, like, isn't that cool? That's actually pretty whack, right? And so, well, here, just plug into neural network. All right, Bob. And so, I just feed in past data here. I just do some stuff to it. Oh yeah, here. I increased the features by taking the percent change. That's what the paper said. Oh, question. Yes, Jaren asked me if this is going to be posted. Yes, this will be posted. Okay,
Thank you.
that's basically the model. Okay, does anyone have any questions? Are there any questions on this model? It's pretty cool, right? Oh, wait, no.
Yeah, so have you like backtested against, say, portfolio allocations that you would get from like traditional portfolio theory, like a mean variance Lagrange multipliers allocation, since you reject portfolio theory so much?
I'm pretty sure this is portfolio optimization. This is a method of portfolio optimization, but it uses a neural network to estimate it.
Mm-hmm.
I'm pretty sure. I think this is probably mean variance because, like, maybe it's like very similar to mean variance. But like, I use a neural network instead of like iterating through all the values. You know, because like if you iterate through like all the possible allocations, it might take forever. But I use the neural network to like use the gradient descent part of it to like get there faster. Okay, I go the here. And then I go other questions. Let me post this if you guys want to see it. Check this out. It's on my GitHub. In the chat. Let me post this in the Discord. I'm gonna stop the recording for now, but maybe we can talk about like. Here, I can talk about my interviewing experience. Okay. Yeah, I'll just keep it on. Okay, so recently I've been. Do you guys want to hear about my interviewing experience with all these different companies? Anyone? Like Jane Street? Oh, nice. We get some good reception. Okay, so here, let me just list them off. Jane Street, Jane Street, SIG, I'm just typing them out right now. Okay, so here, so Jane Street, oh shoot. I don't know if I probably can't talk about the specific questions, but I'll just, because like they might, yeah, I'm not gonna talk about, so it's a lot of stuff like flipping coins, like if you flip like 20 coins, how many you're gonna get. And that's just some basic probability theory. There's a lot of expected value. So here, what's expected value? So say I flip a coin, heads I get $1, tails I lose $1. What's my expected value? Do you guys know? Well, the probability of winning is 1/2 because there's a 50% chance of getting heads. And then, so that's 1/2 times 1. And then how much I can, here, let me type this out. No, here, I'll just put it here. So I have a 1/2 chance, 1/2 chance of making $1 minus 1/2 chance of losing $1. And so 0. Oh, shoot. Plus. Yeah, it does make sense, right? Okay, so it's a bunch of those stuff, but they make it a little more complicated. Okay, so yeah, it's basically a lot of probability questions. It's really hard. It's really hard to get these interviews. Here, wait, no. Here, this is something cool. Let me show you guys my internship tracking. This is hard. Yeah, okay, so this dude, he said like I should contact him in February. But I only get paid like $20 an hour. Like, so someone has to leave during spring, and if someone does leave during spring, I'm like his first choice to like join him during the summer. But it only pays like $20 an hour. It's less than my current internship. You can see this hard. I get ghosted most of the time. Apply to, I know people who apply to like 200 just to get like one internship. Okay, so some important things is like, don't try to like question your interviewer. Like, I sort of try to question my Jane Street interviewer. I think it kind of made him a little annoyed. But for my for my interview with SIG, I was like acting very nice and very enthusiastic. And so I kind of screwed up on the last one, but she like encouraged me and like gave me a hint. And so I figured it out. So make sure you're like likable, like sound likable, because like this stereotype, like all these people are nerds who play chess all day. It's true. They play chess and poker for fun, and when they play poker, they use so much math. They do math. When they go to a sports game, they freaking use probability and matrix algebra to figure out who's gonna win more likely, and all. So like these type of people kind of nerdy, but you want to be like sociable, right? Because like they don't want to deal with nerds. They probably want nerds to go there, but they want sociable nerds. They don't ask stochastic calculus questions. Well, I only got like this dude asked me. Okay, so this dude, the interview for this dude asked me what like an Ornstein-Uhlenbeck process was, and I basically said it's like some Brownian motion, and I talked about like some extra properties. he didn't really go into in depth, which is nice. So I think stochastic calculus, like, it's not the best. You probably don't want to learn. Like, if you want to do well on the interview, you want to do brain research. Oh yeah, there's a bunch of resources. So quant questions. There's like a ton of interview resources. Yes, true. Yeah, we go to UW. But there's this. I know one dude who graduated from CFRM department, and he went. Yeah, research is like tough. Yeah, I think I got no callbacks for research. Like, I applied for Jane Street. I think quantitative trading. Yeah. Okay, so apply for the quantitative trading rules, because that's the only. I've gotten callback. I've gotten like assessments and callbacks and like interviews for when I applied for quantitative trading. Wow, wait. Oh yeah, another tip is probably apply to like asset management firms, because like apply to asset management firms where it says programming experience is a plus. Because then you're competing with all the finance majors, but you're a huge leg up because you're way smarter than them. Asset management firms are probably a lot easier to do. Okay, so for interviews, I say do brain teasers probability. Yeah. Except basic probability, Bayes rule. Yeah, the math is actually quite basic, which is kind of funny. Like, yeah. They don't, and they also don't ask any programming questions. I don't think I've gotten a single programming question or data science question. I don't know for
Yeah, I haven't gotten coding questions for trading, but I have done I have basically gotten lead code rounds for research.
research. Oh, interesting. That's interesting. Um, yeah, the math is actually quite simple, but it can be kind of difficult if you're under pressure. So combinations, like, so you don't want to learn like combinations, combinatorics. There's a lot of it. It's a lot of it. Like expected value, all ties with this. Yeah. What else? Some other tips. Oh yeah, your interviewer will help you a lot. Like for my Jane Street and my SCG interviews, like if you get stuck, you just say out your process, and then like you don't have to ask for help explicitly. Like, I'm kind of stuck here. I'm just gonna say out my process, and then you just go through all the steps, and then they might be able to identify one step that you took wrong, and then they'll like help you out. So they're a friend. Uh, but don't count on getting an internship in this field. Like CS internships are already hard enough, right? But so this is like a hard square. Maybe I think it's hard, like a lot harder. Oh yeah, finance knowledge is not needed. You don't need to know any finance knowledge, but if you know option pricing theory, that might be nice. Well, it really depends on the firm. Like if you're applying to somewhere like if you're applying to some derivatives trading company, you probably want to know a little bit about like futures and options pricing, and that requires some math, but maybe not.
I think they generally don't directly ask you like a pricing problem, but they'll use an analogy.
Oh
And
yeah,
it's basically the same, like some kind of binomial tree thing.
yeah. Yeah, I actually got one. It was on a painting. It was on selling painting. I probably can't say any more than that.
Oh, I've seen that question.
Oh really? Okay. Do you guys have any questions about the interview process? Mm-hmm. And okay, there's also a lot of free books. Like you can just find a book in PDF. Yeah. I'm not okay. So to be honest, I'm not having the best of luck doing like, okay, you guys might think I'm experienced and stuff, but I'm still not getting the best of luck with these internship applications. So make sure you apply early, because like, if you're like even freaking 2 weeks late, your chances are probably zero, to be honest. So here, what you can do, like, just like make sure you apply in August and early September, or else you have like no chance of getting it. Okay, hopefully you guys enjoy that. Okay, that's about it. I don't really have more to say. Okay, I'll just stay around for a little bit. Okay, hopefully you get. I don't know. Are there any last questions? They open up in August. Okay, some even open up in July. Hudson River Trading, they open early in July. Okay, so right now it's probably too late to get an internship in this field. I'm still applying because I'm desperate. Apply in freaking August. There's sometimes they open up. Like randomly you get one or so I put these down in the order I got, like apply. And so this one was pretty late, but I still got it. Well, I think I got it. Like, I'm pretty likely to get this one. So apply in freaking August, please, guys. Apply in August. I applied early September, like so halfway through September, and I was way too late. Oh yeah, sometimes they open up again. Like, so sometimes I like see Veda Labs just like October, like they open up a position again. It's probably someone who like turns down the offer. So, but those. Okay. Okay, I have nothing more. Okay, hopefully you guys enjoy. Okay, see you guys.